Place each of the following numbers at its approximate location on the number line. The square root of 144 is an exact value. It's a perfect square at 12. The cubed root of 1000 is also a perfect cube, and it has a value of 10. So that takes care of those two. Now I'm going to place the whole numbers that I know down here for the 11 squared is 121. So I know 120 is going to be very close, but just slightly under. 115 is going to be a little bit farther away. And then I'm going to check, and I'm going to put 10.5 and square it and see what that gives me, which is 110.25. So 110 is going to be just slightly underneath that. Then I'm going to do 11.5 squared, and that gives me 132.25. So 130 is going to be just below that, and 133 is just going to be right above it. Then I need to look at 115. So I might try 10.7 in my calculator and square it. 10.7 gives us 114.49, and 115 is just slightly above that. Using these values down here as our guide and our explanation, we can place the following or the listed square roots and cube roots on the number line. For this next one, we are asked to determine which hypotenuse is longer. Remember, our Pythagorean theorem says a squared plus b squared equals c squared, and c is that hypotenuse. 7 squared is 49. 2 squared is 4. 49 plus 4 is 53. To undo a square, we use a square root, and the square root of 53 comes out to about 7.28. Over here, 5 squared plus 5 squared equals c squared. 5 squared is 25. When you add those two together, you get 50. So you may already know that this one is larger. Square root both sides. And c equals, or is about, 7.07. But then it asks, how much longer is it? So 7.28 minus 7.07 is about 0.21 units longer in this triangle here.